looking at this equation compared to what we talked about yesterday, how is this different? There's a z and there's a third equation, right? So if you'll remember from yesterday, if we have two variables, how many equations did we need to solve the system? 2, right? But today we have 3 variables, so we need 3 equations to solve the system, right? What if we had 6 variables? We would need 6 equations to solve the system, okay? So keep that in mind, right? We have 3 equations, we have 3 variables, so we should be fine. We should be perfectly able to solve this system, right? Okay? Before we go on with this problem, let me talk about something else real quick. Yesterday, we had answers that ended like this, right? Right? And we knew that on the xy plane, coordinate plane, it was over 2 and up 1, and I had 2 lines that crossed at that point, right? Well, what would happen if I graphed that system? Is that a line? It's not a line with 3 variables, is it? What is it with 3 variables? It's a plane. Like a sheet of paper. It's a plane. So if I have 3 planes that intersect, how are they going to intersect? Will they still intersect in a point? If I've got this plane right here and it intersects with this plane right here, what is it intersecting at? It's intersecting at a line, right? You can see the line that it intersects at right there, right? Kind of. Okay? If I had another plane come in, where's that intersecting? Aren't all 3 of these intersecting right down? Oh no. Right down there at a point? It's still a point, right? Now, is it possible for me to not have intersecting planes? What if the 2 planes are parallel? Will these ever cross? So then it would be no solution, right? What if all 3 planes were right on top of each other? Yeah, everything in that plane, right? Every point on that plane would be a solution. Or basically that plane is the solution, right? Okay, so we just have to be careful about that. So, but today our answers aren't going to look like this anymore, right? They're going to look like this. Because I've got an x, a y, and a z, right? What was this one called? What's this called? Yes, it's called a point, but more mathematically, what is it called? Starts with an O. It's not the origin. What's it called? It's 2 words. First word starts with an O, second word starts with a P. Close. Ordered pair, right? Ordered pair, okay? Guys, if this is an ordered pair, see how it's 2 numbers, so it's a pair of numbers, right? What's this called? That's really close. It's ordered triple. Okay, it's called an ordered triple. So, understanding that 3 planes can intersect in a point, we are still writing our answer as a point. You okay with that? Okay. All right. See if you can keep up with me here, because you know how fast I'm writing lately. Okay. This is what our problem looks like. We are starting out with a more difficult problem, not starting out with a super easy problem. I'm not concerned that you can answer those. I think you can without my help. Okay? So we're starting out with this problem. It's a little bit more difficult. The reason it's a little bit more difficult is because on some of the easier problems, it starts with that. It tells you z is negative 21. Well, if z is negative 21, can't you just put it into some of the other problems? The really easy problems look like this. Z equals negative 21. If I know what z is, can't I put it into the middle one to solve for y? And then put it into the middle, or put those two to the top one to solve for x? Some more difficult problems look like this, where I still know z, but I got to find it. But if I put z into both of these 2 equations, won't I have a new system with 2 equations and 2 variables? And don't you know how to solve that from yesterday? So if we can get to where we were yesterday, don't we feel a little bit more comfortable? 2 variables and 2 equations. Okay, so that's kind of going to be our goal today, to get it to 2 equations with 2 variables. Because we know how to do that from yesterday, right? So the reason this one's more difficult is because all the variables are there for all of the equations. That's okay. That is okay. All right? So we have to decide, first of all, you need to understand that, well, let me try this. You have to understand that this point can actually be graphed. How did we solve these yesterday? What were the 3 ways we used to solve yesterday? Graphing, substitution, elimination. Good. Okay? We could graph this. This is just x and y, right? Well, in order to graph this, what do I need? A z-axis. I've got an x-axis right here. I've got a y-axis right here. The z-axis actually comes out of the paper toward you. It's 3 dimensions. So over 2, up 1, out 3. 1, 2, 3. I can't draw that because it's 3 dimensions. I could attempt to draw a 3-dimensional picture on 2-dimensional space by saying, this is the axis coming straight out of the paper toward you. You're just standing off to the side a little bit. Can you use your imagination and see that? So I could go over 2, up 1, and then out 3. I am not asking you to do that. I'm asking you to keep in mind that we could solve it by graphing, and that helps us to remember how we write our answer. What we are going to do is learn to solve these 3 variable systems with the other 2, substitution and elimination. Today we are concentrating 100% on substitution. Okay, tomorrow we'll do elimination and we'll go from there. All right? So let's start with this problem, solving by substitution. What's the first thing we do when we're trying to solve a system of equations by substitution? Find the easiest variable. Which is the easiest variable in this problem? Which x? The third x? Is it the only easiest variable? There's the z. Which z? The third? Okay. Oh, also on the first? Does that mean that the first y is also an easiest? So which one do you choose? The z? The first z? The first one? So we're going to solve for the first z. Is everybody okay with that? Okay. If I solve the first equation for the first z, how do I do that? I get it by itself, right? I'm going to get it by itself by subtracting 2x from both sides. And I'm going to get it by itself by subtracting y from both sides, right? So what I actually end up with is z equals 12 minus 2x minus y. Okay, so far? Thinking back to yesterday, when I solved for a variable and plugged it into another equation, what happened to that variable I was solving for? It went away, didn't it? Okay? So that goes to the same reason that if I plug what I know for z into the second equation, won't the z go away? And won't that give me one equation with x and y? If I have one equation with x and y, what do I need? Another one with x and y. So couldn't I take the same idea, take the thing I know for z and plug it into the third equation and make z go away and have an equation with just x and y? Okay, so what do you want to do first, middle one or bottom one? Third one, okay. So I'm going to rewrite the bottom equation, this third equation, but instead of writing the z, I'm going to put in what I know for z. So I'm going to write x minus 4y plus all of that. Now there's no multiplier. If there was a multiplier, I'd put it with parentheses, right? I'll go and put the parentheses just so we can have a conversation about it. 12 minus 2x minus y equals negative 21. Now, why did I say I'm going to go ahead and put the parentheses there so we can have a conversation about it? Are they really necessary in this exact problem? No. They would be necessary if there was a 2z or something like that right here, right? There's not, so I can just go ahead and pretend they're really not there. There's not a multiplier I need to worry about. There's not even a negative sign in the front. If there was a negative sign, it would be important. I'd have to distribute that negative sign to everything, okay? So what do I do now? Combine your like terms. I have an x and a negative 2x. So that gives me negative x, and then I've got a negative 4y, and I've got a negative y. So negative 5y. Now, what was my goal again? To get an equation with just two variables, right? To get rid of the z. I'm getting rid of the thing that I'm substituting in for, right? So, do I have an equation so far that it has only two variables? Do I want to go ahead and write the 12 down right here, or do I want to do something with the 12? What do I want to do with it? I want to subtract it from both sides, because when I subtract it from both sides, I'm giving myself a really great equation with just two variables because everything's where it's supposed to be. Variables are on one side, all the constants are on the other. So a negative 21 and a negative 12, negative 33. Okay? Now some people from here want to like try to divide by 5, or they want to divide by negative 1 or something like that. What was my goal? Get an equation with two variables. Have I done that? Then I need to step back from that. I need to leave it alone for a minute. Okay? Because my first goal was to get an equation with just x and y. And I chose x and y because I already solved for z. I'm already trying to get rid of z. Okay? If I have one equation with x and y, what do I need? Another equation with x and y. So I started by taking z and substituting it into the bottom equation. Now I need to take z and substitute it into the middle equation. Now, here's a conversation that I had earlier. I want you to tell me what's wrong with the conversation. I said we substituted into the bottom equation. Where do you want to go now? They said the top equation. And I said why? And they said it's easier. Is it? Is it easier? The numbers are smaller, right? But didn't we use the top equation to solve for z? If we plug z into the top equation, that's not going to tell me anything. Okay? It's going to end up being like negative 12 equals negative 12, and we already know that it does. It doesn't tell me anything. Okay? So, even though it's quote-unquote harder, the numbers are bigger, like 5 is a big number, we got to use the middle equation. Okay? So I'm going to do just what I did before. I'm ignoring this writing right here. I'm ignoring this work for a second, doing just what I did before, except this time with the middle equation. Saying 5x plus 5y plus 5 times. Now this time are the parentheses important? Yes, because I have that multiplier there, right? The 5. So I've got 12 minus 2x minus y equals negative... What? Oh, sorry. Regular 20. I panicked for a second because I realized that said negative 21, and I was like, oh no, what have I done? You caught it. Thank you. What do I do first? Distribute. Good. Here, here, and here, right? 5x plus 5y plus 60 minus 10x minus 5y equals 20. So here's what I'm hoping is happening, okay? I'm hoping you're doing this on your own because it's taking me forever to write this out. I'm hoping you're doing this on your own and then checking to make sure that we got the same thing. Is that fair? Okay, let's combine like terms now. Can we do that? 5x, negative 10x. So negative 5x. What? Look. Negative 5y. Sorry, positive 5y, negative 5y. Oh my gosh, that's amazing. Now, if that didn't happen, maybe if they were both negative, I would just write negative 10y and equals 20, and then I would have two equations with two variables and then solve it just like I did yesterday, right? This is a lucky break. Because this, if I subtract 60 from both sides to get all the constants together, this just equals negative 40. And what have I just found? My x. Because when I divide by negative 5, I get my nemesis. 8 is not normally my nemesis. I don't draw 8s left-handed very well. And I know that looks fine right now, but look how many times I had to reposition my pen to make it look really nice. Because my brain wants to say, do I go around this way and back, or do I come around this way first? And so sometimes my brain just short circuits and it just goes straight down like a 1. And I'm like, what are you doing, hand? What are you doing? So that's fine. We'll go on. Okay? But here's the cool thing. I just found one of my parts of my answer, right? What should I do with this? Where? Where do I want to plug it in? The easiest one. The easiest one happens to be right here. Why is that the easiest one? It already only has two variables, right? It already only has two variables. So if I take it right up there right now, I'll say negative x, which is 8. Oh no, I'm sorry. Minus 5y equals negative 33. Now we can solve for y. It's exactly right. Add 8. Oh no. Can we pretend that's an 8? Ugh. Negative 5y equals negative 25. What's y equal? Yep. And so now we can plug them in for z. Now, some people earlier wanted to go over here to the original equations. Is that a possibility? Is it the smartest possibility? Where's the smartest possibility? Here, right? Z is already solved for right here. Go back here. Z equals 12 minus 2 times x, which is, of course, the dreaded 8. Minus y, which is 5. Z equals 12 minus 16, which is negative 4, minus 5, negative 9. Now I have to figure out how to write my answer. How do you know it's that order? It's alphabetical, right? X, Y, Z. Okay. 8, 5, negative 9. Just like I told you yesterday, or just like I asked you yesterday, will we always write our answer like this? Most of the time, yes, but no, not always. Sometimes there'll be a better way to write our answer, but I promise I will make it clear, and you'll know exactly when to use that. Okay? To use the other way versus this way. Okay? Any questions about this? Here's the deal, guys. When you start working on your homework problems, you're going to look at the first one and you're going to say, man, something's wrong because this is way too easy. It's not. I gave you some easy ones to start with. Okay? But here's the deal. If you have an equation with two variables, that's our goal, right? Solve for one of the variables, plug it in somewhere to get an equation with two variables. Then plug it in somewhere else to get another equation with those same two variables. Some people are trying to solve for another variable and plug it in. That's going to just get way too confusing. Solve for a variable, plug it in 2 different times. Okay? We happened to luck out in this example and we got accidentally solved for a variable. That was good. Okay? But if we would have gotten 2 equations with 2 variables, we just start again. Do what we did yesterday. Solve for a variable, substitute it in. Got it? Any questions? Ma'am. How did we get the beginning? You're asking me at the end of the problem how I got the very first step of the problem? We talked about the fact that this y, this z, this x, and this z would be the easiest to solve for because they were all by themselves. Okay? And someone said, I said, which one do you want to solve for? And someone said the first z. So we chose to solve for this z. We subtracted these 2 things from both sides to get this z by itself, and that's how we started. Okay? Any questions?